Hi everyone, welcome to this lecture. Today we are going to cover the 7 basic tools of quality. It's a simple visual method that anyone can use to solve problems and improve processes. Popularized by Karo Ishikawa, these tools are used worldwide by companies like Toyota and form the foundation of quality improvement practices everywhere. Our lecture's agenda. We'll start with the introduction to quality tools, then we will have the overview of the Ishikawa's 7 basic tools of quality, and we are going to dive into each tool one by one, from process maps, check sheets, histograms, scatter plot, control charts, cause and effect diagram, and Pareto charts. And we'll finish by showing how these tools work together as an integrated system. So what exactly are the tools of quality? Well, think of them as your problem-solving toolkit for quality and process improvement. These tools of quality are used to identify, analyze, and solve process problems. They can help us to make decisions based on facts rather than just gut feeling or guesses. And they are essential for effective quality management and continuous improvement. Here are the 7 basic tools of quality. Process maps visualize workflows. Check sheets collect data. Histogram show distributions. Scatter diagram test relationships. Control charts monitor stability. Cause and effect diagram find root causes. And Pareto charts prioritize problems. They work best together. Ishikawa believed 95% of quality problems could be solved using just these 7 simple tools. A process map is a visual picture showing how work flows through a process from start to finish. It's crucial because you cannot improve what you don't understand. Process mapping reviews problems, redundancies, and bottlenecks by showing how work actually gets done, making it essential the first step in most process improvement projects. We can use standardized symbols in the process mapping, such as diamonds for decisions, rectangle for processing steps, and arrows for flow lines. There are several key rules, which include using symbols consistently, starting general steps, and then adding details. Interview people who do the work, and we also need to distinguishing value added from the non-value added steps. And last but not least, we need to question whether the work needs to be done in the first place or not. There are 6 steps involved in process mapping. The first is to agree on standard symbols. And second, we need to communicate the purpose clearly. And the third one is to observe work by shadowing employees. And then based on that, we develop the map. After that, we review it with workers to verify accuracy. And after verification, we create an improved future state map. This systematic approach ensures we solve the right problem and get everyone aligned on the current reality and improvement targets. This example about drilling permit application flows, the process map clearly shows us the permit flows with decision points, activities, and complete passes from start to finish. It makes the invisible visible. Instead of vague complaints about the slow permits, we can identify specific bottlenecks like decision points where applications wait unnecessarily. These detailed information provided by the process map lay a solid foundation for us to implement corrective actions in later stage accordingly. Maps are not just for mapping what happened inside your own organization. They can also be used to map extended supply chain that involve multiple companies and organizations. SIPOC is an acronym that stands for Suppliers, Inputs, Process, Outputs, and Customers. With two of the SIPOC, we can improve complex multi-organization systems. And SIPOC diagrams are especially popular in Six Sigma projects because they can help teams to understand the bigger picture before diving into detailed improvements. Another widely used approach for mapping extended supply chains is called value stream mapping. This technique, which came from the Toyota production system, maps not just the flow of materials, but also the flow of information through a supply chain. It helps identify waste, like excessive inventory sitting in the warehouses, unnecessary transportation, or waiting time between steps. Value stream mapping is incredibly powerful for companies trying to implement lean manufacturing or lean service principles. Check sheets are simple data gathering tools providing structured forms for recording information in real time. They can be tabular, computer-based, or schematic. To create one, first we need to identify defects to track, draw a table with defects in rows and time period in columns, and then mark occurrences. They provide the foundation for data-driven decisions. These check sheets are example review that non-standardized set of routines occurred 315 times, which account for 52.1% of all problems. Other issues include missing equipment, unseparated tasks, and resetting needs. And this check sheet transforms vague concerns into actionable data showing exactly where to focus. Fixing standardization alone would eliminate over half the issue. That's something we can infer from this cheat sheet, and it really facilitates our data-driven decision-making. Histograms graphically represent data in bars showing how frequently values occur. They are used for continuous numerical data like time or weight, but not categorical data. Histograms reveal patterns from our raw numbers, whether data clusters around a value, spreads widely, or skews to one side. All those help us understand the variation fundamental to our quality improvement. There are several key rules for developing histograms. The first one is bar width must be consistent. Classes must be mutually inclusive with no overlaps and all-inclusive covering all data. And we can use the formula K should be greater or equal to log n divided by log 2. Here the n stands for the number of observations. This histogram example, we have 40 data points, and which has the mean value of the 4.2 and the range of the A16. And based on the formula of number of classes k, we can calculate the result is 5.32. So we use 6 classes, and class width is 8.16 divided by 6, which is equal to 1.4. This creates 6 non-overlapping classes from 0.76 to 915. This resulting histogram transforms 40 numbers into visual insights about the distribution pattern. Diagrams test whether two variables are related by plotting paired data. Independent variable on x-axis, dependent variable on y-axis. Upward patterns suggest positive correlation. Downward patterns means negative correlation. Random scatters suggest no relation. They move us beyond assumption to test whether suspected relation should actually exist, providing evidence for our decision making. There are 4 steps for setting up a scatter plot. First, we need to determine our x and y variables. Gather paired measurements for both variables. Plot each pair as a point with labeled axes and observe patterns, looking for trends, relationship strengths, and outliers. Remember, correlation doesn't equal to causation, but scatter diagram identify relation worth investigating further for our evidence-based decisions. Example of scatter diagram plots 30 employees' overtime hours versus days absent. The pattern might reveal if more overtime causes exhaustion and sick days, or if factors are unrelated. Scatter diagram force us to test assumptions against the reality. Combined with other tools like the interviews or cause and effect diagram, we can to have the complete picture of the real issue. Flow charts determine whether processes produce consistent results by distinguishing common cause variation from special cause variation. They plot measurements over time with center lines and control limits, normally at 3 standard deviations. Points within limits indicate control. Points outside or unusual patterns require investigation, proactively detecting problems earlier. Cause and effect diagram, also called Ishikawa diagram or fishbone diagram, can help us identify true root causes, not just symptoms. And we can use the 5 whys techniques, asking whys repeatedly to dig deeper. For example, late deliveries because trucks leave late, because orders are not ready, because picking takes longer than usual, or because the warehouse is disorganized, or because no standard system exists. All those will reveal to a fixable root cause. In order to create a cause and effect diagram, we need to first to state the problem specifically in the fish head, and then draw backbone and ribs with major categories like 6 M's or 4 P's, as 5 Y's to add causes and sub-causes, identify which root causes would have biggest impact, and set specific goals with responsibilities. And all this will transform vague problem into actionable items. Pareto chart is a very effective tool to identify and prioritize problems to be solved, and we also call it 80-20 rule. In simple terms, which means 80% of the problems come from the 20 of the causes. And this bar graph sorted from largest to the smallest, including the cumulative percentage line, and showing where to focus our limited resources to attack those vital few causes rather than the trivial many, and which we can maximizing our improved impact with our minimum efforts. To construct Pareto charts, we need to follow several rules. First, we need to use the categorical data on defect types, and data must be collected and classified into clear categories. And then we construct frequency charts, sorting in a descending order. And there are several analysis steps involved. By getting those data, we draw the chart with cumulative line and focus on the tallest bar first. And often the first 2 or 3 categories account for most problems, and we want to fix those and solve those majority of the problem. Okay, let's wrap up this lecture. These 7 basic tools of quality work best when used together in a cycle. Flowchart to standardize the process, and we can use the check sheet to collect data and test relationships with scatter plot, and monitor the process with control charts, analyze the distribution with histogram, and find root causes with fishbone diagrams. And last but not least, the Pareto chart can prioritize the main issues. And this is a systematic and data-driven problem-solving approach. And these 7 basic tools is very simple and accessible, but will create powerful results. So I hope everybody can learn it and use it. Thank you.